Hi, my name is Connie Arzigian, and I work with the Mississippi Valley Archaeology Center at the University of Wisconsin-La Crosse. Today I want to talk to you about chipped stones, how we can tell how they were made by past people, and how we can recognize them from natural stones. So chipped stones are made by using either a hammer stone or an antler, or sometimes even a copper-tipped pressure flaker, and many artifacts are pretty easily recognizable. This projectile point is pretty clearly human. We can have flakes that will have a very distinctive configuration of an edge, and we'll talk about a bulb of percussion so that you can recognize the chips that come off of making tools. And others are pretty clear, but then we're going to try to explain how to distinguish these artifacts from stones that are broken naturally or that have distinctive fractures that we know were not made by human. You can check the timestamp in the description box to go directly to particular links. Thank you. The first question is, what are chipped stones and how do we tell them from natural rocks? So I have an example here of a number of artifacts that are clearly culturally made. We have a nice archaic projectile point that's been well chipped, it's been nicely shaped. This is another example that we can tell was probably used and damaged because there's a chip off the side of it, but it's still clearly human. We've got other materials here that have very distinctive traits from the flakes that are removed. I'll talk about what that means. And then we have some materials here that are natural, and I want to talk about what separates them from these cultural materials. So the process of chipping means that you take a tool such as either this antler or this hammer stone, and you take a stone, and it could be an initial piece of material that you're just working, or I have here a stone that has been worked for a while, and I'm now going to show you how to take off some more flakes from it. So you can see we have a nice set of flakes off of here. In order to continue working this, to shape it, this edge isn't terribly straight, it's kind of a rough edge. I want to get it a little bit straighter. The process of flint knapping or chipping stones means that you find a surface that is less than 90 degrees. It often follows a ridge. Here's a point right here that is sticking out. It's got a nice what we call platform. I can hit it here and knock off that flake. So if I were to actually strike this here, and this is a demo, so I've already removed the flake, but we'll just pretend that I'm going to strike it here, and the flake is going to come off. And so what we have here is a removal of a flake. It's got a nice set of force marks. You can see they look like ripple marks flowing through the stone because the force of hitting this right here sent force through the stone and created these marks. So we have what we call a negative bulb of percussion here. We have a dip in the stone right there, and we have a positive bulb of percussion here. Where this hit the stone, we have that bump. We have the raised area that is marking the point of impact. So this is a flake. It has all of these ripple marks flowing through it. It's got very sharp edges. In fact, the flakes that come off of chipping stone are some of the sharpest things ever created by humans. This edge is probably 10 to 15 microns thick. Surgical steel would be on the order of 100 to 115 microns. So we have a seriously sharp tool here. This flake on its own could butcher a deer, could do an awful lot of different kinds of activities. And I know it's cultural because I knocked it off, and I want to show you some of the characteristics that are going to be marking different kinds of tools like that. So we can see here another object that's been clearly worked, and it has many of these negative bulbs. It has dips on the edge, on the surface, where you can see the ripple marks coming through. The ripple marks don't have to be there, but quite often they are. But there's a dip, there's a negative bulb, and there's a series of those that come off on each edge. So we can mark that flakes were taken off of one face by hitting from this direction, turn it around, hit it from the next direction, work all around all the different sides. Here on this edge, we can see lots of tiny little flakes that were removed in order to work this margin. So we can see a series of small flakes, but each of them has this same negative bulb of percussion on the surface, and the flakes that came off of that have the positive bulbs. Here's another example. These are very high quality materials, so they really show this process well, that dip. So you can see here the area where the flake was hit and it was removed, and you have this dip. Another dip here, another dip here, another dip here. And each of these, this flake took this whole surface off, but the point of impact was on the margin. So each of these has chips removed from the edge to shape the stone. It could be on high quality materials like this. These are varieties of cherts and flints. This is called a dacite. These are cherts from the Wisconsin and Iowa and Illinois area. This is an orthoquartzite from Wisconsin. These all have a quality of the stone that chips where you want it to. It doesn't have its own crystalline structure, so you can control it. This orthoquartzite is coarser grained, but it still has these dips. It has a systematic series of dips all along the edge. We get to a natural stone, and it's got fractures, but it doesn't have that systematic pattern. And each of the edges, while it's broken, and there are places where it's broken all along the edge, but they're not hit at the corner, and they don't have impact fractures moving through them. This one kind of looks like it would, but this is in fact broken naturally. The deepest point, the point that should have represented the bulb of percussion, is actually in the center of the rock, which means that it wasn't being done by a human. This was being done by, this is actually a nodule that fractured along a natural plane. The bulb should be on the edge. Humans couldn't have removed this because there's no way of getting and hitting right in the center of that rock there. And these other fractures, again, are straight. They don't actually have bulbs along them. They don't have those regular surfaces. So that's one of the ways we could look to see what chipped stones are versus some just naturally fractured stones. The best materials for flint knapping are those that have no structure to them. They're what we call cryptocrystalline. So this would be something like the cherts or the flints in Europe. Some of these orthoquartzites that we find around here that are sandstone that has been cemented so tightly with silica around the sand grains that it's actually breaking through the sand grains. So these have no structure of their own. When they do have imperfections, fault lines, frost lines, they tend to break along those, as what happened with this one. So the desire for finding stone is to find it with the least amount of inclusions, the least amount of other kinds of material that would interfere with flaking it the way you want it to flake. So there's some examples here of just a wide range of different kinds of material, some of which are really high quality and may have been traded over very large areas. We have examples of Knife River chalcedony. It's almost a translucent material that's coming from South Dakota. We've got materials that are just varieties of different kinds of cherts from all over North America. So these are high quality materials that flake the way humans want them. Hammerstone is made out of an igneous material that really doesn't flake the same way. It kind of crushes. You can see here in using it, it is fractured, but it's not chipping the way we would want it to chip, which is why we use it as a hammerstone rather than trying to make tools out of it. The ultimate material for flint knapping would have been obsidian, and we have this flake here, which is a very, very sharp flake. This is volcanic glass. It is extremely sharp. It will make extremely sharp edges and cutting tools, but it's actually pretty brittle, so this edge is not going to last terribly long. This orthoquartzite is much coarser. It's a nice quality material, but it's much coarser than the obsidian. A flake off of this will never be as sharp as an obsidian flake, but it will also last a lot longer. We've done experiments with these where we can take an obsidian flake and use it to try to cut down grasses to see how long the material would last. And an obsidian flake gets dull pretty fast. The silicified sandstone flake is never as sharp, but then it never really starts showing too much wear for a long time. For an hour or more, we can still use them. So there's a different kind of material, different kinds of things will be good for certain purposes, and then others they might be selected for different kinds of activities. Some materials are used in areas because there's nothing else. Quartz is one of the materials that's the most common in the central Wisconsin area. There's no sources of the bedrock, of the chert, or this, we call it either silicified sandstone or an orthoquartzite. Central Wisconsin doesn't have it. It has a lot of quartz. Quartz has its own crystalline structure, which means that it fractures more or less where it wants to. It can be made into artifacts, but it's pretty hard. A lot of the materials are found as little quartz pebbles. And how do you flake something like that? You can't hold it. You would put it on the ground and you would hit it from the top and the bottom, shattering from the top and the bottom into something that might end up with shattered pebbles of quartz that, if you're lucky, will come up with things that you can then continue to use. So say, well, boy, that sounds like a hassle. That's why a lot of the high quality materials are traded widely in prehistory. People really want to get access to them, particularly in areas where they don't have good quality materials to work. The final material here, this is a piece of a pipestone product, and it doesn't chip the way we would see these. It's going to be more of a kind of pecking it and grinding it surface. On the other hand, it's a very important stone that people would have used for making things like pipes. So other materials are certainly of value, but they won't be used for chipped stones. Flakes are the most common thing found on archaeological sites. A lot of times they're the only thing left because the people who were making a tool took all the tools, they left all of the debris behind. So we have here examples. Many of these are coming from my experimental work, so I know how they were formed, but they are exactly like what we would be finding in archaeological sites. And there are a couple of characteristics we can learn from the flakes. Besides what kinds of tools they were making, we can learn about that process. So tools that they might have been using would have been this hammerstone, which is a hard material. It's as hard as the stone. And an antler, which is actually softer than the stone, so it compresses and actually makes a much softer, gentler flakes, smaller bulbs of percussion, flatter bulbs of percussion. So if we look at a hammerstone, we can see that it's got a prominent bulb of percussion. This was a large platform. It's a large bulb, and it was probably hit by a hammerstone. You can see on the outer surface that there are the flakes that came off before this particular flake came off. So we have remnants of the previous flake scars on the outer surface. We'll call this the dorsal surface. We've got the platform at the top, and the inner surface with the bulb is the ventral surface. So this would have been inside the rock when it was hit. This was in a rock, it was sitting like that, it was hit, it came off from underneath the stone. So we have examples of dorsal surfaces of flakes with very prominent bulbs of percussion, very distinct platforms, the points of percussion up here, and the previous flake removals. In terms of removing these flakes, you might have to grind this edge a little bit, platform preparation, so you'll see lots of tiny little flakes and crushing coming off of the very surface here that the flint knacker did to prepare this platform before knocking off the flake. So hard hammer flakes will have prominent bulbs of percussion, and they will usually show a very prominent platform too. Antler will dissipate its force a little bit more. It will actually flex and bend a little bit into the stone, so its bulbs of percussion tend to be flatter, and that's better in later stages of flint knapping because you don't want to have really prominent big dips. You want longer, flatter surfaces that you can control. So this is a soft hammer percussion. The bulb, you can feel it, but it might not be terribly visible unless you're really looking at it. The platform is much smaller, and the dorsal surface shows that it has the similar patterns as previous flake removals from there. Here's another example of one that has a relatively flat surface for the bulb, but a nice large flake from that. And flakes can come in all sizes. When you're flint knapping, you might be producing hundreds of flakes in an hour in order to just make a few tools. So we've got a series of different flakes here. I said most of the time the ventral surface will be smooth. We won't have flake removals from it. The dorsal surface will have previous flake removals. But sometimes when you're hitting the platform, you get kind of a 2-for-1. You might get little flakes popping out right at the bulb. So this flake depression here actually came off when this whole flake was being removed, and it left this little hole right there from it. But that's still a deliberate human flake with all of these other flake scars on them. Sometimes we will get odd little things. So we have, this is a flake. The human knocked off this piece of stone, but what they knocked off ended up getting thrown in a fire and burned. And we've got tiny little holes on the top of this, so we call pot lids, where there was moisture in the stone and was in the fire, and they literally just popped off. So humans couldn't get in there and take off these tiny little perfect circles in there. So those are little pot-lidded flake on there. So now you have some ideas on how to tell a real artifact from a real flake that a human chipped off of a stone, even if it's a simple biface that they were working, and how to distinguish that from something that broke naturally. So be sure to check our other videos in the sequence. Is it an artifact? Because there's lots of other things out there that get confusing. And our website, that is also linked in the description box, will have more information about both the cultures as well as other kinds of stones, and we'll have links to all of the different state archaeologists in the United States. So if you do find a site, you do have cultural material that you'd like to report to an archaeologist, you can find out how to do so. Thank you.